All right, everyone. So if you haven't heard already, you would help to install Git while we're going over some of the conceptual things. It is git-scm.downloads, or just Google Git. Do not Google GitHub, as we will cover. They are very different things. So git-scm/downloads. If you are on Windows and you already have Git installed, make sure you also have Git bash installed. That is the correct way to use Git for Windows. If someone tells you otherwise, they're lying to you. Or have a different opinion from me, which are similar. Also, at some point before you leave, make sure you fill out the survey to give us a little bit of feedback on it. So just to gauge the audience real quick, raise your hand if you are a CS major. Okay, raise your hand if you are a CM major. Raise your hands if you are another major. Okay, lower your hands if you code using that major. So if your hands are raised, you're not super familiar with coding, and this is okay. I'm going to do a little bit of coding, but that's not the focus of what we're doing here today. So if that freaks you out, don't worry about it. It's fine. Git is most useful for software people, but anyone can use it because it's great. So we're going to jump into it a little bit. To introduce myself, since I forgot to do that, I'm Joshua Redding, as you see here, one of the Computational Media Ambassadors. I'm a fifth-year computational media major with like 85 minors and stuff, so don't worry about that. And Git personally was something that terrified me coming in, because I came into tech not really ever having coded before, and then all the people that like have been coding since elementary school were like, yeah, I just use Git all the time, and I've got like an Apache server and a bunch of terms that they don't actually know what they mean, just to help you de-stress. Git is not complicated, and we'll learn it today. Cool. So, without further ado, so like I said, while we're learning, install Git. So we're going to do a quick conceptual introduction of Git. What is Git? So, according to the website, Git is a free and open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. That's a lot of information, so let's break that down. So, it is free and open source. Good. You don't know what open source means? Don't worry about it, it's good. Designed to handle everything from small to large project with speed and efficiency. Great. It means you can have a small project, it means you can have a large project. Git will work for both. Git will work well for both. That is great. Distributed version control system. This is what we're going to break down as the little emoji will tell you. So, version control system. Basically, what a version control system is it assigns a version to each file and it keeps track of it. This doesn't have to be complicated. If you've ever had like an essay and you're like SAV1 and then you copied it and you called it SAV2, congratulations, you implemented your own version control system because you're controlling versions. Pretty simple. Your computer automatically does its own sort of like version control with timestamps. If you've ever noticed, you open up Windows Explorer or Terminal or any of another 100 different applications, it'll show like the time something was created. Your software will keep track of versions, typically only the most recent versions. So, what Git does is it saves the changes you make to a file. And it thinks of each file as a series of those changes. So rather than like your computer might do, or like you did when you were like SAV1, SAV2, that takes a lot of space because you have all of SAV1, you have all of SAV2. Like we said earlier, it works for small and large projects. That might work for one essay, but let's say you're doing something with gigabytes worth of software. You don't want to do that. You want something more efficient. And so Git will save the series of changes, and it's very good at what it does. Don't worry about how Git was made. It was made by the guy who makes Linux. So basically, it's complicated. So here's an example of version control. You might have, this is a file, and then later on you say, this is a file, it is a good file. And then later on, you might change this first line and say, we'll delete the first line and then add, and I like it very much. Git sees you're adding, this is a file, to nothing. And then you're just adding a new line and it is a good file. There's no need to store the second copy. Git's just like, hey, let's just add this little piece here. And then later on, you just deleted these first two lines and then you added these last two lines. That is how Git thinks of things. So the easier this is to understand, the easier Git's going to be to understand. Also, at any time, if I go too quickly or if I see something that makes no sense, just like raise your hand, be like, help. Like that. Go ahead. What's up?
What happens to the it is a big file line? Shouldn't that also be
So Git doesn't need to store this because nothing happened here. All we did was we deleted the first 2 lines, then we added these other lines. So Git doesn't say anything about a good file because it didn't remove or add. It's just been there. This isn't actually kill this. This is just a little divider I made. So Git doesn't actually care about it as a good file because it's just been there because it was here and you didn't remove it. Sort of like on a dry erase board when I draw a picture, as long as I don't erase that picture, it's going to stay there until I physically erase it. That makes a little bit of sense. Good so far? Alright, moving forward a little bit. You noticed in the URL it says git-scm. What Git is it is a source control manager. It is a VCS SCM, version control system, source code management. Basically what that means is Git was specifically designed to work for source code, not for, let's say, images or sounds or videos or your essays that I used the example earlier. It's not really made for that. It's made for source code. It is optimized to work super well for source code, and though it may work for some other things, it doesn't necessarily work as well. So let's say you're in some giant coding project, you're probably going to have some images, you're probably going to have some videos that like maybe your game is using or maybe your web app is using. And Git will control those, but it won't handle that like deletes line, adds line, because it would be deleting and adding like series of binary characters, which wouldn't really make sense to us. And so Git will do it, but not as well. We'll kind of get into that later if we have time. So to break down this last part of it, distributed version control, Git is version control that can be tracked across multiple different computers. This is the crux of why Git is important to you as a coder. Anyone can make their own version control system by copying and pasting, but Git handles the distribution part well. It means you can use Git for version control entirely on your computer if you want to. There's no need to connect it to some web server or some network or other things. You can just control your own projects on your own computer with Git, and it'll work great. Or you can connect to other computers over a network, and then you all work on the same project at the same time. Git is the industry standard for collaboration, meaning we are all working on the same project, and Git handles those individual pieces of it very well. That's why Git's great. One of a few reasons. I'll say that's why Git's, I will say that's why Git is great a lot. I promise they're all reasons. None of them are the only reason. If you can't tell, I kind of like it. Brief point here. This is often a point of confusion with people. Git is not the same thing as GitHub. GitHub is a hub for repos. We'll talk about what a repository or a repo is later, but for now, just note that Git and GitHub are not the same thing. The relationship is kind of like Burger King. You wouldn't just say, like, burgers and Burger King are pretty much the same thing. No, no, no. Burger King's a place where you go to get burgers, but you don't eat Burger King. It doesn't make any sense. You don't say, like, on your resume, I know GitHub. That would be silly. You know Git, which is software you might use with GitHub. And we'll talk about GitHub somewhat towards the end, hopefully. This is the most technical part. So if I go too quickly here, let me know. Git thinks of your project as like 3 trees. It is called the 3-tree architecture. And we will show examples of this later, so if the pictures don't perfectly make sense in your head, that is okay. Basically with Git, you have a working tree, a repository tree, and a staging tree. Working tree is what you are working with, the actual files on your computer. So congratulations, you all, of every project you've ever made, essentially have a Git working tree. Even if Git doesn't know it exists, it's there. The repository tree, or the repo, or the commit tree, you'll hear it mentioned with several names, is the most up-to-date operational version of what you're using, or at least it should be if you're doing Git right. This basically means, you hear the term commit a lot, it means the changes you've committed to being part of your project. You will make lots of little minor edits, and you'll do some typos, and you'll backspace some typos. As you're typing, you make thousands of little edits. But when you commit to the repository tree, it means this is the series of edits I want to track as something that I can add or remove to my project. You wouldn't want individual character of every word to be part of that. That would be kind of silly. So if you're working on a project with others, you're going to share a repository. This is the only tree you will have in common. Sort of. We'll talk about that again a little bit later after we get the basics of Git down. Cool. There's my dinner. All right. You can see I have a great diet. Honey bun and Taco Bell is how I feel myself. So, the last one is the most confusing, but the easiest to use, I promise. It's the staging tree. So basically, in the predecessors to Git, before Git was invented, they just had this working tree and this repository tree. And there's a lot of weird problems that we don't need to go into. The creator of Git, Linus Torvalds, again, Linus, Linux, some trivia about how he named Git, which I will not cover, exists. But the staging tree is sort of a halfway point. You don't want to have all of your changes and just stick them in the repository like as much as you want. It makes more sense in a lot of cases. You put your changes into this staging tree, and then eventually you push that staging tree into the repository. You commit the staging to the repository. And we'll talk about those terms a little bit later, but does this conceptual idea make a little bit of sense? Ask a question if it doesn't, and I will show you an example. Cool? Oh look, it says example. So I'm going to pull the board up real quick and hopefully it'll work. Alright, so we'll do a drawing over my head, but it'll be fine. So basically, in Git, in your folder you have a example.java, for example. And so example.java, here's our first set of changes. We've added the first little bit of the file. If you don't know Java, don't worry about it. This is not a Java tutorial. You've made a few changes to your code. Then you are going to put these changes in the staging branch. And later on, you may make some more changes. And then you will add these together into the same little staging piece, this version of your file. And then once you are satisfied with those changes, you're like, all right, this is a piece of my project. This is one little part of the unified whole that will be what I'm making. You will commit it to the repository. So you have all these changes, you're putting them in staging, and you're moving over to the repository. This is a full cycle. So this process right here is called add. You are adding changes to staging. That is the term I will use from here on. You are adding changes to staging. You are moving them from the working branch, I meant to write working, you're moving it over to staging, and then you are committing those changes to the repository. As time goes on, you may make some more changes, you may move them to staging, and then let's say I want to push this to the repository. If you've taken an algorithms class, you realize this works a lot like a linked list. They're very similar. This change are the changes before this change, but this one depends on this. This does not exist without this previous component being there. So we're going to keep adding up changes that together make up our project. And there can be varying versions of staging and varying versions of working, but when we get it to the repository, they are all pieces of the whole that will be our project. We're making a little bit of sense. So we'll add a little bit more to this later, but for now, let's just sit there. And put this down. So now that we have the basic conceptual stuff out of the way, we're going to do some actual live code. So, I am going to, I have a folder that's just on my desktop, and I have my, let's open a new one, git bash. So if you don't have git bash installed, this part may get a little confusing, but it's okay. Just sort of follow along in your head or with your notes or whatever. So I'm going to, well, real quick, slide aside. Git bash is a program that is a bash interpreter. Don't really worry about what that means, but think that as if you were on a Linux computer or a Mac computer, you have your terminal, the program called terminal, is what's called a bash interpreter or a bash shell. It has actually both of those components. They can run various commands, including git. Windows computers don't use bash. They use 2 or 3 other different things, which are kind of terrible. Git works with those. You can absolutely open command prompt. You can absolutely open PowerShell and do git things. But they look a little funny because Git was written by the guy that wrote Linux, and so it works like Linux. You don't have to know Linux to understand Git, I promise. But I highly recommend if you are on a Windows and you are using Git, you do it in Git bash, which is your own little bash interpreter. You can use this like a Mac command line or a Linux command line. It is literally the same thing. Kind of the same thing. Mostly the same thing. If you're on a Windows, you can use this. I actually use this instead of command prompt in 100% of situations because it works the same, just a little bit. So that is what it is. If you're on a Mac or if you're on Linux, just open your terminal and it will be effectively the same thing as this, although it may look a little different. So, to use Git, we need a project. So I'm just going to create a folder on my desktop and I'm going to call it, I don't know, Git in all caps. That's a silly name. Let's think of a better name. Example. It'll make your life easier if there's no spaces in it, but do what you want. I'm going to throw it on my desktop and we have example. So we've got this project here. And let's say I'm coding something in Java. So I'm going to open up my text editor. This is a program called Sublime Text. If you don't have Sublime Text, don't worry about it. Notepad works fine. Or if you're on a Mac, TextEdit works fine as long as you save as, like, not RTF. Don't worry about that. I prefer to use Sublime Text because it's great. Just don't use Microsoft Word. I promise you'll regret it. So, we're going to create our first Java file. Again, if you don't know Java, don't worry about it. On the desktop, I'm going to put it in this level up folder, in this example folder, that's our project folder, and I'm going to call it example.java. So, in our folder, we have some source code that we can use with our source code manager. And I'm going to just put some basic stuff in here. If you know Java, this will look familiar. If you don't worry about it. Google class example and the main function. And I'm going to say something like system.out.println. This is a tutorial. If I make any typos, don't worry. It'll be fine. So I've got this Java file in our folder. So first things first, if you've ever worked with Java, you know that Java doesn't do anything unless you compile it. So we're going to compile Java. Do you remember how I said earlier you can use git bash like command prompt, just better? I didn't lie to you. So we can enter our desktop. Oh, it's going to be silly to me. We're going to make this work. So, a little shortcut. If you install git bash, you probably also install something where it says git bash here. That saves you the work of actually having to go there. So, please ignore that little brief technical difficulties. I just typed the path wrong, and I don't like being wrong. So, we have this, and I'm just going to compile that file, example.java, and just so that if you believe me, it works. We have this little Java program that just types this as a tutorial. Again, if you don't know Java, don't worry about it. quick little break. Is this too small? Can people see this? Or is it just too low behind things? This is what's most important, so I'm going to move it up here. Just make it big. Why not? So I'm going to make this a little bigger so people can see it a little better. Options, text, like this one. Cool. Can everybody read this? It's a good size. Great. So I've compiled my thing. Now, right now we just have a Java project. We want to add Git. So if you have Git installed, all it takes to add this is git init. And this is the syntax we're going to be working with from now on. Everything you're doing with Git will be git space whatever the git command you are doing. And we will talk about various git commands and what they do over the course of this tutorial. So git init, like it says, initialized into git repository, and there's the path to my thing right now. If you go to this folder after we have git initted, you will notice I have this little folder called .git. It's a hidden folder, so if you go to yours and you don't see .git, it's there, I promise. It's hidden because it doesn't want you to mess with it, because you usually don't. But the cool thing about Git is that it doesn't leave all these little weird traces all over your computer. Everything Git will ever do involving your project is contained in that folder. So let's say I am tired of using Git with this project and I don't want to use Git anymore. I just delete this folder, and congrats, you have a regular blank Java project with no Git attached whatsoever. That is all it takes. One of the several reasons that Git's great. Git init. So we're back in Git. This is a Git project. You may notice Git bash tells you this like master thing here. We'll talk about what that means. If you don't see that, it's fine. It's just not telling you some information that so far you don't actually need to know. So, time check. We're good. Great. So we are in our Git folder. Your next, I'm going to pull up my notes so that I don't skip things real quick. Okay. Cool. So we've initialized Git. Git exists. I'm about to introduce to you the most revolutionary thing in all of computer science. It is the git status command. Git status. Type git status, hit enter. Okay. This line, git space st, or however you spell that, enter, is something you will type probably every other line for as long as you're working with Git for the rest of your life. Git status is very fast, and it tells us most things we need to know about our project. Namely, what's in those 3 trees we talked about. So, starting from the top, your on-branch master, we'll deal with that later. No commits yet, meaning we don't have a repository tree. It says untracked files. This is our staging tree. We'll look at this a little bit later. And then you sort of have these files just hanging out in our working directory. Fortunately, this actually tells us what our next step is. It says, nothing added to commit, but untracked files present. Use git add to track. So, as you may have guessed, we're going to say git add, and now we're going to say what to add. If you remember, adding is what moves it from our working directory, our working tree, to our staging tree. So that's step 1 of our process. So git add, and then whatever we're going to add. I'm going to add example.java. All right, so we're going to slightly move this around the way it'll actually scroll correctly so you all can see it. Cool. Well, or don't do it. Cool. All right, so we type git status, and git status says no commits yet. We still don't have a commit tree, but it says changes to be committed. Basically, this is what is in our staging tree. You can notice we have a new file. It's called example.java. It is now in our staging tree. This green means it's in our staging. And we have untracked files, which Git is currently not thinking about. Basically, Git doesn't want to assume that something's part of the project unless you've told it it's part of the project. Git doesn't just go and think that everything under this folder is part of the project. You have to actually tell it that by adding it or by tracking the file. And we'll look at some more examples of that. But right now, our Git tracking is going over example.java. It is in our staging tree. And so Now we want to put it in our repository. We want to complete the final step of this little addition to create this Git project. If you remember from earlier, what we're going to say is git commit. Git commit takes some arguments, usually. Typically you're going to say git commit -m, and then you're going to type a message. This commit message is what everyone is going to see when they're looking at this repository. Let's say you're working with like 15 people, and they're all looking at the same repository. You don't want to just stick changes there with no message. They're going to have no idea what those changes are. So instead, you add a commit message so that when they see this commit, they see this little bunch you added to the overall whole that is the project. They want to see what it did. For now, we're just going to type in little one-liners. We're going to say something you will see a lot, initial commit. This is the standard for the first commit you do, initial commit. So we're going to send that. Cool. And it will tell us, I suppose this is kind of low for people at the back. So I'm going to move up a little bit here and scroll down. Cool. Git commit -m initial commit. We hit enter. It says a bunch of things that we'll talk about later. And it says 1 file changed, 5 insertions. Do you remember how Git thinks of things as like adding on and removing things? We added those 5 lines. We added these 5 lines to the nothingness that was our repository. Cool. 1 file changed, and we made it. So, what are we going to do now? You guessed it, git status. So git status tells us what is the status of our thing. It no longer says, if you remember earlier it says no commits yet, we now have commits. So it doesn't say you don't have a tree yet, the tree exists. So on branch master, like I said, we'll talk about that later, we still have some untracked files because we haven't told Git that example.class is part of the project. Again, if you know Java, class is a compiled Java file. And generally, you don't want compiled files to be part of your project. Because you want things in your project to be things that other people just couldn't create for themselves. They're creating for themselves, they're compiling it on their own machine. You don't want to include the compiled file in there. We'll talk about how to ignore that later. It's called git ignore, which you would probably guess. But for now, we're going to leave it how it is. So, we have this thing here. So, let's say, cool. So, thus far, we have our Git project. Let's say we want another file, because most projects are going to involve multiple files. So I'm just going to create a new one. I'm going to save it as other.java. And other is just going to be a file with another function that prints out something. So let's just say public static void introduce. And introduce is just going to do that same thing we did earlier. This is a tutorial. So we have other. So we have 2 files in our project now. Let's go back to example. And we want to actually use other. So I'm going to remove this line entirely. And I'm just going to say other dot introduce. Again, what I just did here is a Java thing. If you don't know Java, don't worry about it. But suffice to say that we now have a project that is using 2 files. So we're going to go back to our command line. We're going to compile, well, let's say first our new other.java, and we're also going to if I can type correctly, example.java, compile our 2 Java files, just so you believe me, it works. We're just going to say example. It's going to say this is a tutorial. So now we don't just have example existing alone. We have this other file that example is using to actually do its printing. So if we go to git status now, we got a little bit more info. So Git tells us changes not staged for commit. Basically, what we think should be on your staging branch, but is not currently on your staging, not branch, your staging tree. it says that you've modified example.java, which we did, but we haven't staged those changes yet. It also says you have two more untracked files that you had previously. You have other.class and you have other.java. Well, as you might have guessed, we definitely want other.java to be part of our project because it is part of our project. So just like before, we can say git add other.java. No feedback is good feedback. Add doesn't just add files. It also adds changes. Again, git add just adds changes from our working to our staging. So we can say git add example.java. It says right here, modify example. And it says git add file to update, like it's telling us exactly what we're going to do. Git add example.java. No feedback is good feedback. Let's look at status again. So this says changes to be committed, meaning here's what is currently our staging tree. A modified version of example.java and a new file, other.java. This is precisely what we've done this far. Make sense? And we also still have those untracked files. I'm not going to git add example.class and other.class. Like I said earlier, we don't want them as part of the project. So we're not going to. So we're going to say git, we're going to say commit, so earlier, we just said git-m, and we had this little one-line example of what we were going to say, like adds another file for introducing. Often, we want a little bit more information about our commit than just that single line response. So if we type git commit, and we leave off this -m, or we type the -m and then nothing there, yours will look different than mine, I hope, unless you chose Vim. If you did, I'm sorry. Git is basically saying you want a message. You would never, ever, ever want to commit something with no message. But since you didn't put a one-liner, you probably want a more detailed message. You want to give this whole summary of what happened to yourself in the future or whoever's going to be looking at this repository. It opens up your default Git text editor. You can change this. That is beyond the scope of this course. Just Google how to change that. Mine is Vim. Which, if you don't know Vim, is the most terrifying piece of software ever invented by computer science. But for now, we can just say, our first line, which we mentioned earlier, adds other file for introducing. And then later on, we can say more things about it. This is our full description. I added another file for introducing because it made a great example. You don't need to see this every single time you do this. Yes?
Just a clarification, when you're saying that, perhaps I missed this, when you're saying that Git records things in terms of changes, are you saying that it is recording a whole new copy of the repository with the changes? It's modifying the original remote repository, or it's creating some sort of reference file that just records what changes were made?
That is a great question. It is creating a reference file for the changes. And I will dive into that in just a second. You've reminded me that that's important. Thanks. So, like you said, Git doesn't just create new versions of all these different files. It's just storing the changes you have made to them over time. Yes?
I have a possibility of Git add and my domain issue that right now there is no
What do you go ahead with that? Okay, I'm going to get someone to help you with your specific problem. And if it's something that I forgot, let me know. So, let's just save this, which of course would be :x because Vim makes sense. Git commit saves this. If you can't tell, I love Git, I hate Vim. It's just how it is. Git commit will commit this thing. So we have another commit. Now that we have two commits, it's kind of hard to just memorize what's going on. Git status will only tell us that we have a tree, that we have a repository tree, but it won't actually tell us what's in it. I'm now going to introduce you to your second friend in all of Git, right after I answer this question. Yes?
So like when you leave the -m off and you get that like prompt to type a message, like
How do you like commit? Because if you said you did like semicolon X or something.
You just save it.
Right,
So whatever text editor it opens, you type out the answer and you save it, and the minute you save it, Git is going to close the text editor and commit it. Just automatically. Yes?
Why do we need a staging tree?
You need a staging tree for reasons that are kind of complicated. Mostly because you want to be able to put little changes here and there to have things in your repository that aren't part of the project. So the author of this is me. So if we're working on a giant project, they all know I did it. It says when it was done. It says my little message. If I had a longer message, like I did for this one, it will say the entire description of what this commit was. And then it will say our next commit. So this was our first commit, or this is our most recent commit. This was the commit before it, our initial commit. That's why we called it that. So basically, our repository tree currently has this commit and this commit. Does this make sense? So, for anyone who might be curious, and this answers your question you asked earlier, if we open this up and we go in our .git folder, we have a lot of odd things here like refs, heads, and tags. These are what is storing our individual commits in a series of very complicated files that look something like that. Don't attempt to read those files because they only make sense to Git, but suffice to say they are there. These commits, I'm just going to go back to the example folder. These commits have names, but they're not names that you understand, unless you're very good at pronouncing whatever this says. This is called the SHA. I didn't name that. Capital S, capital H, capital A. It is an acronym that we will not define here, but the SHA is the hashed out series of all of your changes. This is the name of this commit. And this is the name of this commit. They will all be unique across most of the known universe. This SHA references this specific commit. So if I want to see, well, we'll get into this later, but if I'm referencing commits, you don't have to type out this entire name. Because these are so unique, the first like 6 characters will do. Because the odds that these 6 characters also are the first 6 in other commits you'll do in the future are extraordinarily low. So the first 6 characters is generally good enough to reference it. We'll talk about referencing commits later. But suffice to say, we have a tree working. So, do you have any questions thus far? Yes?
Do you keep referencing the .git folder that's like actually in your
Yes.
thing? I don't see that in my...
It's a hidden folder.
Okay.
So if your operating system settings are that show hidden folders, it will show it. It's there, or else Git would not work. If you can't see it, there's a couple of ways to like get around that. You will never actually need to see it.
Okay.
So don't worry if you can't see it. If you're curious, you can type ls space -la. That will show all the things there, including hidden things. Right here. Yes?
Why did you say we need to show those like commit reference numbers again?
Right now we don't.
Okay.
Later on, we will want to do things like ask Git, hey, what changed between this commit and this commit that happened 4 years ago?
Oh.
You can say, what happened between these 6 characters and these 6 characters? And it will do all of that for you. But we'll cover that a little bit later. Hopefully, if I don't run out of time. So, we've got that, we showed log. So, one thing that Git does, as you may have noticed, is it does track files. What it does not track is it does not actually track folders. So if I just create, well, first I'm just going to say git status. I told you I type this a lot. We can see that there are untracked files of class and class. So if I go in here and I create a new folder, and I'm going to call it other folder. And I go into Git and I say git status. It didn't say anything. Git doesn't concern itself with folders. It concerns itself with files. It cares if those files are in folders, but not about the folders themselves. If that confuses you a little bit, don't worry too much about it. Just know that if you create a folder and you commit it and your friends are like, you didn't create the folder, it means that Git doesn't care about that folder because it doesn't have anything in it. Of course, if we add something in it, that's a different story. So in our project, we're going to create yet another file. We're going to save it in our other folder. We're going to call it third.java, because I'm incredibly creative in coming up with names. So we've got to do this, or else it won't work in Java. Public class third. And this doesn't actually have to do anything. Let's just leave it like that. So we have this third file that exists in the world. If we go back to Git, and now we say Git status, it will say untracked files, other folder, slash. Bit of trivia, not trivia, just a quick, I don't know what to call this. Why do you think it doesn't say other folder slash third? Because it's the only file in that folder, and all files in that folder are being untracked. It doesn't want to list out, let's say we have a folder that's not being tracked, and there's 38 files in that folder. If the whole folder isn't tracked, it's not going to waste our time by saying other folder slash this, other folder slash this, other folder slash this. If nothing in that folder is being tracked, it'll say everything in other folder is not being tracked. Let's fix that. If I say git add, so we want to track, I'm going to type correctly, other folder slash third.java, and hit enter. No feedback is good feedback. And I'm going to type git status again, git status. And it will say changes to be committed. Basically, this is our staging tree. New file, other folder slash third.java. We now have a tracked other folder. And it doesn't have that other folder here thing there because there's nothing actually in there that isn't being tracked. A little confusing. Don't worry too much about that. We have a new file, other folder, third.java. So we can git commit. We're going to send a message. We're going to say adds a third file in a new folder. Do yourself a favor, when you're working on a real project, don't type commit messages like adds a new Java file to the project, because your teammates are going to hate you. Type something useful to them. Type like adds the wrapper class for the UI, or something like that that makes sense for your project. The general convention, we'll talk about conventions if we have time, for commit messages is present tense and say what the commit is doing. Don't say what you did. Don't say like, I fixed some bugs. Say, this commit fixes these bugs. Because later,